to this RCR Wireless News webinar on the LTE device ecosystem, design, test, launch, and repair. I'm RCR reporter Kelly Hill, your moderator and the author of RCR's upcoming special report on the LTE device ecosystem. I'm joined today by representatives from a number of companies with unique perspectives on the LTE device space. Our analyst guest today is Olga Yashkova-Shapiro, Program Manager for the Test and Measurement Practice of Frost & Sullivan. Olga will be giving us her insight on trends and challenges ahead for LTE devices. Our carrier speaker is Wade Smith, Vice President Products and Innovation for Spire, which has launched an LTE network in its southeastern United States service area. Wade's responsibilities at Spire include product evaluation, deployment and maintenance of all applications, services, and devices for Spire customers, and he'll speak to the carrier side of the device selection and launch process. We also have Venkat Nara-yanaiah of Alcatel-Lucent, who is Director of the company's business development for 4G devices and solutions within its Wireless Competency Center. We'll hear from Venkat about how network equipment company Alcatel-Lucent is also working on the LTE device side. And from Anritsu, we're joined by Business Development Manager Mike Barrick, who's going to help us understand some of the challenges in pre-launch testing of LTE devices and the importance of both carrier acceptance and conformance testing for LTE devices. I'm going to start off with a brief summary of the special report that accompanies this webinar. RCR's look at the LTE device ecosystem found that the number of LTE devices and device manufacturers is exploding as customers look to LTE to provide the speeds and capabilities to really make the most of wireless access. However, there are definite challenges. A huge number of spectrum bands are used for LTE deployment, both worldwide and domestically. This poses challenges for scalability, especially for device manufacturers. LTE Advanced is in development, but there are issues, for example, with increasing numbers of MIMO antennas in LTE Advanced that have to be addressed. Carriers are expected to move to voice over LTE, but it's crucial to get the quality right. And testing is a critical piece of the pre-launch puzzle, with fallback needed to prevent or to more prevalent 3G and even 2G networks. And overall, everyone I talked to was insistent that partnerships and planning were key to a successful LTE device launch. You can read more on the LTE device ecosystem in our report, available this week at rcrwireless.com. But first, we'll move into getting the perspectives of our presenters. We will have a Q&A in the last 15 minutes or so of the webinar, so if you have questions, please submit them through the webinar interface. If your question is meant for a specific presenter, please include his or her name so we can get it to the right person. And now we'll start off with Olga Yashkova-Shapiro from Frost & Sullivan. Olga?
Thank you, Kelly. Could you please move to the agenda slide of my presentation? Thank you. Hello, everyone. In my portion of the presentation, I would like to talk about the state of LTE device test equipment market, talk about key test equipment vendors, provide a quick geographic overview of opportunities, and list the key LTE device market trends, and go into more details on the two of them, MIMO and voice over LTE. Next slide, please. 2012 was an important year for LTE deployments as it symbolized the technology becoming a wireless technology of choice for global wireless operators. Currently, there are 145 commercial networks deployed in more than 65 countries globally. And in addition, more than 95 LTE networks were launched in 2012 alone. Also, according to GSA, the number of LTE devices increased almost twofold from 269 in January of 2012 to 560 devices produced by 83 suppliers by November 2012. From a test and measurement perspective, the emergence of this highly complex and technical technology creates a large number of opportunities for vendors. The global test equipment market generated $945.8 million in revenues and is expected to exceed $2.8 billion mark in 2018, growing with a compound annual growth rate of 20.7% from 2011 until 2018. If we look at the pie chart to the right of this slide, we can see that LTE mobile device test equipment contributed the largest share, about 53.5% to the overall LTE test equipment market revenue. Most of the revenue, however, still comes from the research and development sector. With rapidly increasing number of LTE devices, LTE mobile device segment is expected to continue experiencing a double-digit growth and offer numerous opportunities to all players in the LTE device ecosystem. Next slide, please. Currently, there are a number of vendors offering testing solutions for the R&D and manufacturing stages of the LTE mobile device test equipment market. The companies are Airflex, Agilent Technologies, Anritsu, National Instruments, Rohde & Schwartz, Spire Communications, Teradyne, LightPoint, and others. Please note that the companies that I just listed are in strictly alphabetical order and not in the order of significance. According to Frost & Sullivan's analysis, the revenue from LTE device testing is expected to increase from $506 million in 2012 to $1.5 billion by 2018. The increasing complexity of mobile devices, particularly that of smartphones and tablets, drives the demand for wireless test equipment in the manufacturing environment as well. With the industry shift from 3G to 4G wireless technologies, test equipment has to test legacy technologies such as 2G and 3G in the same box. From a protocol standpoint, test equipment should conduct all the necessary signaling and handover tests to simulate a dropped LTE call scenario and its fallback to 3G or 2G. In addition, due to increased data traffic, there is a demand to test technologies such as Bluetooth and Wi-Fi and others, despite the fact that they have been in the market for a long time already. Because of complexity associated with smartphones due to their multi-band and multi-mode design, the amount of testing is increasing exponentially. In addition, the increased cost of testing leads to discontent among original equipment manufacturers. Next slide, please. The demand for LTE-enabled devices is expected to experience a healthy growth as more operators are deploying LTE, which is why LTE offers tremendous opportunities to the entire supply chain, service providers and carriers, OEMs, ODMs, EMS companies, as well as the chipset manufacturers. LTE will continue creating opportunities for test equipment vendors as well at each stage of the product lifecycle, such as research and development, R&D, manufacturing, and installation and maintenance. As you can see from this slide in front of you, LTE device ecosystem consists of 5 stages. The first stage begins with the baseline chipset development, and this is the longest stage, I would say. It takes between 15 to 18 months, sometimes even 20 months, to develop an LTE chipset from scratch. Then the cycle moves to development of hardware and software requirements. After that, integration of hardware, software is taking place, but still not the final form factor. Later, the cycle moves to finalizing form factor of the device, including RF and antenna verification. And finally, develop an execution plan that consists of implementation stages, strategies, validation, conformance, and carrier acceptance testing, production tests, and finally, release. I would like to point out that approximate life cycle for LTE device is about 2 years, and that is all the way from chipset to handset, with less than 6 months for just handsets. Any period of time longer than that suggests less return on investment and lost early-to-market advantage. Finalizing hardware and software starts mid-frame of chipset development, or once they get an idea of which direction they intend to go in. Once design is approved, transition to manufacturing is a matter of months. It is absolutely crucial for service providers and OEMs to deliver devices to market as early as possible. Early time to market is critical for OEMs, otherwise they'll start competing on price alone. Testing becomes a critical part of bringing devices to services to market early, because it is very important to comply with industry standards and deliver high-quality products and services to their end users that not only meet but also exceed customer expectations. Test equipment is needed to help all the links in the supply chain. component manufacturers, handset manufacturers, operators, and laboratories that conduct compliance testing, helping them to get through the R&D cycle as quickly as possible while ensuring the quality is good. Test solutions that provide good ROI for service providers and OEMs are in great demand. Next slide, please. As the number of LTE-enabled mobile devices is multiplying, industry is expecting new entrants into the LTE device market, such as Amazon, for instance, and others in 2013. As LTE networks are being rolled out globally, the demand for LTE devices is expected to come from United States, United Kingdom, Japan, and some of the emerging countries such as Russia, Brazil, China, and South Korea. In addition, mobile data consumption on smartphones and tablets are driving the demand for operators to expand their LTE networks as well as their LTE device portfolios. Next slide, please. Thank you. This slide illustrates the most current trends in the LTE mobile devices. They are ensuring positive quality of user experience, voice over LTE, Wi-Fi, MIMO antenna technology, cellular offload, and indoor location capabilities are among the most current trends in the LTE device market. I would like to touch upon a few of them and how they impact testing. Next slide, please. Complex nature of MIMO. The multiplication of antennas is one of the key challenges engineers face while deploying LTE. This challenge will become more critical with the introduction of LTE Advanced. 2x2 MIMO, where base station transmitters and receivers have 2 antennas on each side, have been deployed with LTE. While Release 8 is expected to expedite the industry's move to 4x4 MIMO, Release 10 that came out in 2011, LTE Advanced, will introduce 8x8 MIMO, where 8 antennas will be required for every transmission. This will present significant challenges for service providers and OEMs because implementing 8x8 MIMO will require significant design changes due to interference and the ability to divide the signal. For MIMO to operate properly, signals will have to reach the headset via different channels to pull data and provide users with the high data throughput they expect. And if the signals are too close physically, it becomes difficult to decorrelate them. The challenge for mobile device manufacturers is to design multi-band MIMO antennas with an acceptable decorrelation method within the limited space of the mobile phone. Moving on to the next slide. Thank you. LTE technology brings about a major industry shift to a packet-based data network. Because of that, service providers will deliver voice over a packet-based network, also known as voice over LTE. Typically, UMTS and HSPA solutions support voice calls in their core and radio network. However, in the case of LTE, voice calling depends on the emerging IP multimedia system, or IMS solution. And the progress regarding IMS to implement LTE with voice capacity is slow. The lack of standards for IMS and, incidentally, mobile voice has driven service providers to identify the appropriate voice calling techniques to embed into their LTE networks. Telecommunications industry is currently working on refining voice over LTE technology through the entire LTE ecosystem, beginning from chipset and all the way through network. Testing during the research and development phase of voice over LTE becomes absolutely critical for successful technology deployment and ensuring positive quality of end-user experience. Some of the benefits of voice over LTE are listed in front of you. They are lower cost of operation and additional revenue from IMS services, such as rich communication services and visual voicemail. Voice over LTE brings along a number of challenges, such as poor battery performance, voice quality issues, and poor call setup time. I would like to touch on a few of them. According to the study conducted by RCR Wireless, now Spire Communications, calls conducted on voice over LTE consume twice as much power as those over 2G CDMA network. As a result of the findings, battery life of the handset would drop from 502.6 minutes of CDMA call time to just 251 minutes of voice over LTE. The first LTE-capable telephones were known for their poor battery life, and flipping between circuit switch voice calls and LTE for data was said to be one of the key reasons for this. So poor battery performance of voice over LTE calls will be a concern of the industry. However, with proper testing, the performance is expected to improve. Industry now has to have a brand new LTE backhaul in the network, which has to handle the voice packets and traffic in a way that isn't designed to discriminate between individual packets being carried across the network. Latency is going to be critical. Voice quality is going to be an extremely important metric for service providers and device manufacturers to ensure that it is sufficient and that they can guarantee a good voice quality over LTE networks. Customer experience is compromised with voice over LTE because of call setup times is approximately 4 seconds rather than a sub-second call setup time. Because of the issues mentioned, just mentioned, voice over LTE testing should include development testing, conformance testing, interoperability testing in order to ensure good quality of end-user experience. Next slide, please. The evolution of LTE technology is expected to create significant demand for test equipment. As LTE is also used in mission critical markets such as healthcare, military, and public safety, additional demand is expected to come from this vertical. Frost & Sullivan believes that existing test systems in place are still not quite fully equipped to cater to the increasing demands of LTE mobile device testing market. However, the situation is changing, and the number of new and advanced features are added to test equipment every day. Significant demand for new and integrated test systems is anticipated due to the increased adoption of LTE technology by telecommunications players. This concludes my presentation. Back to you, Kelly.
Okay, great. Thank you, Olga. For our audience, we are going to have our first poll of the webinar. And the question is, what kind of reverse logistics process do you use for LTE devices? We're going to go ahead and launch that poll. And then we'll take a look at the results in a few minutes. So please, audience, go ahead and vote. And in the meantime, we're going to move on to our carrier guest, Wade Smith of Spire.
Hi, Kelly.
And Wade,
thanks to RCR.
Yes, thank you for joining us. I'm wondering, Wade, if you can start out by talking with us a little bit about some of the device-related challenges that are associated with being a smaller carrier who has launched an LTE network.
Yeah, happily. Not to state the obvious, guys, but fundamental to smaller carriers is first determining what band to build. Given the aforementioned device fragmentation, the absence of certain interoperability requirements is critical to start with choosing either a developed or a soon-to-be-developed device ecosystem. I can suggest to you, at least from Spire's experience, that we chose a band and immediately, or at least after some level of exploration, had to reverse our decision and choose a different band and deploy now at band 25. So that decision is critical to make sure that the ecosystem is developed enough to supply those devices that you seek. Another thing that we found was that you're frequently engaged in one-off negotiations. For the smaller carriers out there who are possibly accustomed to buying via a consortium or perhaps a distributor, that's likely not the case at this point in development of the device ecosystem. So what you have to do is go to the OEMs, and it's more of a one-off negotiation for band inclusion, or in some cases multiple band inclusion. And in some instances, those ecosystems aren't ready, so it's even the mix of bands that you have to be prepared for. Other challenges you face is making decisions related to the UICC. The CDMA carriers out there will appreciate that typically we're not accustomed to dealing with SIM cards, so this is a new experience for those carriers. So that presented a challenge for us, both forward-looking and in the back-end systems, OSS, BSS, for example. And then obviously still the ecosystem has to develop so far as device roaming options are concerned, and that relates back to some of the aforementioned interoperability issues. So I'd say those are some of the high-level challenges we faced, at least initially.
Okay, great. Well, I'm going to go ahead and close our poll. And it looks like we are looking at, in terms of reverse logistics, we're looking at about 50% of our audience that involves returning to manufacturers. We've also got 38% returning to a depot for a triage test, and we've got about 13% discarding the return devices. So Wade, let's continue with you. Thanks to everyone who participated in that poll. We'll have a few coming up, a few other ones coming up here. You mentioned the cards and the differences that makes in the devices. Can you talk a little bit about the retail side preparation and training and marketing that is involved with a device launch and how that factors into making the device launch successful? I know that some cards can play into that as a detail.
Yes, I'd say retail training is critical to the launch. There's a lot of mixed messages out there about 4G, so you have to make sure that your retail associates are trained properly and educated properly as to 4G. For us particularly, it was an education process even to discern the difference between 4G LTE and the other versions of 4G that exist out there, HSVA and otherwise. So it's that high-level and fundamental education that's critical on the front end. In addition, education regarding the benefits and use cases of 4G, benefits of the new speeds that you can realize, but also perhaps for some retail associates, you need to get out there in advance if possible and help them understand what the data consumption is like. I think depending on the rate plans of each individual carrier, there may be some concern on the part of retail associates that you might run into some data caps or limits or rollover or whatever those rate plans may be. So I think helping engender some level of familiarity in addition to some level of security regarding the product as it is. You mentioned specifically UICC, and again, for those GSM carriers out there, that's probably not a drastic transition, but for us, as a CDMA carrier, it was a new experience. We needed to get out there, put the devices in our retail associates' hands and help them understand that it's really a simple process. We attempted to handle most of the complexities in the background within our systems, but still allowing them some hands-on training really helped facilitate a seamless transition from 3G to moving in and playing 4G devices. So we found that very helpful as well.
Okay. And one more question for you, Wade. How has C-Spire's launch of LTE changed its device portfolio, and what is C-Spire looking for in future devices?
No, it drastically alters the mix, as you might expect. Once you get out there with your marketing message of 4G, the consumer's expectation really changes. And in fact, we've seen that most consumers immediately expect that every device is 4G, and we all know that that's not the case. You have inventory, you have a device mix and portfolio that consists of 3G and 4G devices, so I think you need to be careful to distinguish between the two. We've also seen that outside of some certain iconic devices that people don't necessarily know, care, or associate with G's, that the inclination is always to go for the 4G devices one might expect, even though if they have to pay a little bit more to get those devices. So it really altered the mix. It forced us to move into a position of pushing our 3G devices down into more of an entry-level type of position, which we expected to do. But ultimately, for the immediate future and then beyond, we're going to try outside of perhaps a prepaid product or two and maybe a very entry-level type device that there will be no more 3G devices in our roadmap. We're focused exclusively on 4G going forward. As the ecosystem develops, component parts come down, we think that's possible in the very near future. So we will have a device portfolio almost entirely composed of 4G devices.
Okay. big change. All right. Great. Thank you so much, Wade, for your time and participation here today. We are going to be moving on to Venkat Nara-yanaiah of Alcatel-Lucent. Venkat, do we have you here? There.
Yeah, can you hear me, Kelly?
Yes, great.
Okay. Good afternoon, folks, or good morning, folks. This is Venkat Nara-yanaiah from Alcatel-Lucent. I'm going to be giving you a perspective of where LTE devices are today and how the ecosystem is being developed globally, with a lot of focus on North America, of course, and more important, tell you what Alcatel-Lucent has been doing in the LTE device space. Next slide, Kelly. Okay, just a brief introduction of who Alcatel-Lucent is. All of you are familiar, I'm sure, about Alcatel-Lucent. We've been in the LTE space for quite some time, and we have deployed a number of LTE networks with Tier 1 carriers and Tier 2 carriers in North America, and we are expanding that to other countries, including China Mobile, some networks in in India, and other locations in South America as well. And in terms of the number of contracts we have to date, we have about 33 contracts, and 40 plus are currently in trials. We have, on the 2G, 3G space, we have about 347 customers today which are being served, which averages around 30% of all the wireless subscribers. Next slide, Kelly. So just a brief overview of how is Alcatel-Lucent helping the LTE device ecosystem. So Alcatel-Lucent has been working on the LTE device space for almost 3 to 4 years. And what we are really doing is we don't build, we don't manufacture, we don't buy or sell devices. But what we are really doing is helping our carriers enable a number of LTE devices. And we have started this activity for the Tier 2, Tier 3 carriers in North America. And as far as Tier 1 carriers are concerned, since they have a very good ecosystem and partnerships with a number of device vendors, we do a lot of device testing for them. But for the smaller carriers who have difficulty getting devices, one of the areas which Alcatel-Lucent has been focusing is we have partnered with a number of device vendors, and through these partnerships, we are enabling small supply agreements whereby the carriers who buy Alcatel-Lucent infrastructure can benefit from the negotiated pricing which Alcatel-Lucent has with the device vendors at very small volumes. So one of the challenges which we are seeing with a number of Tier 3 carriers is that they are able to only place a small volume PO, and they are able to, they want devices which are more affordable. So we have gone ahead and signed up some agreements with the Tier 2 vendors who use Tier 1 solutions from Qualcomm, and then we work with the carriers to make sure they get the benefit of these devices. And we are working with a number of Tier 1 and Tier 2 ASIC vendors as well as device OEMs. We have a very close collaboration. And with the ASIC vendors, we make sure that the chipset roadmaps are fully covered in line with the market requirements. These chipsets are tested in our device labs, which is worldwide. And from a device OEM standpoint, depending on the devices which the carrier requires, we make sure the device is fully tested before it gets to the carrier network. In the case of a Tier 1 carrier, the devices which are deployed in their network are tested fully before they go to that carrier network as well. The final point of this slide is what I mentioned earlier. on the enablement, on the device enablement, we position low volume and affordable LTE devices. And we have started this activity for the Tier 3 carriers through some supply agreements with the Tier 2 vendors. Now, initially, the devices which we have looked into is the USB dongle, the Wi-Fi router, the outdoor CPE, and the MiFi router. And the high-end solutions is going to follow in 2013. So the advantage which the carriers have with this kind of a model is that they get access to the devices which Alcatel-Lucent has successfully negotiated at small volumes, at affordable pricing, and all these devices are fully tested in our labs. And Alcatel-Lucent does not mark up any of the devices, and all the commercial transaction takes place between the carrier and the device vendor. Next slide, Kelly. So this is just a chart which gives you a picture of all the vendors we've been working with. Not all of them have brought devices yet to the table, but there is a fair amount of chipset vendors and device OEMs. So from the Tier 1 chipset side, Qualcomm, of course, is the leading chipset vendor in North America. And then from the Tier 2 perspective, you have a GCT, and then there are smaller chipset vendors like Altair, Sequans, Broadcom, etc. But they are all in the test phase still trying to get their chipset certified. But from a multi-mode standpoint, today Qualcomm is the leader. And from the device OEMs, as we are already seeing, the big ones, Apple, LG, Samsung, Moto, they're already playing the game here, and they are heavily trenched into the North America market. But from the Tier 2 standpoint, there are a few vendors who are really doing their best to get into this market. Franklin Wireless is one of them. And then we have Anritsu, who has sold some devices. We have Sierra Wireless. And I believe in 2013, you will see many more Tier 2 ODMs and OEMs coming into this market with the respective form factors. Next slide, Kelly. I included this chart to give a picture of where LTE devices are today. The GSA Association publishes this information on a quarterly basis, and today it says that 560 LTE user devices by form factors are available globally, and on the right-hand side of the chart, it gives a breakup of the different bands. For the U.S. market, of course, you're looking at the 700 megahertz, including the AWS band. And as TD-LTE becomes a requirement for the North America market in band class 41, you will see some of those devices also coming up in 2013. So this picture is just to give you a breakup of the different types of form factors and the number of devices which are currently available for GSA. Next slide, Kelly. I included this chart just to show the growth. Now in February 2011, we saw 63 devices, which expanded to 417, and now in November 2012, the number is 560. And as I mentioned earlier, the feedback which we have been getting by a number of Tier 1 and Tier 2 OEMs is that as we go into 2013, the number of devices and the form factors will increase. In terms of the form factors itself, 2013 you're going to see many more smartphones, tablets, MiFi routers coming up. The dongles is likely to go down the sales, and our projection is that by early 2014, the dongle may just disappear from the market. Next slide, Kelly. I included this slide just to show the audience what kind of pricing we are seeing from the Tier 2 OEMs. Now, given that the Tier 3 market specifically wants low-volume devices, now I have included 10K as the base, but we are also seeing the Tier 3 carriers requiring pricing in the 2K and 3K model, and the partners who we work with, Alcatel-Lucent works with, offer these kind of volumes at the appropriate pricing for the desired form factors. So this is my last slide. So in summary, I just wanted to mention that while Alcatel-Lucent is not building or manufacturing or selling or buying devices, we are helping carriers with enabling the LTE devices with the desired form factors through our partnerships. We have started that with the Tier 2 ODMs or OEMs, and we will expand that to the other form factors like smartphones and tablets sometime in 2013. So anyone who's an Alcatel-Lucent customer can get the benefit of these devices at low volumes and at the negotiated pricing between Alcatel-Lucent and the device OEMs. So that's my presentation.
Okay.
Kelly?
Great. Thank you so much, Venkat. We are going to do another poll here. Our next question is, where do you anticipate building LTE devices? So we'll have that poll open here for a few minutes. So please, audience participation is appreciated. Mike, our next speaker is Mike Barrick from Anritsu. And Mike, why don't we go ahead and get started with you?
Thanks very much, Kelly. Good afternoon to everyone. Can you hear me okay?
A little bit louder, I think, would be good, Mike.
Can you hear me now?
Yeah.
Good. Thanks very much. If you could go to the first slide.
Mm-hmm.
For some reason, I don't see that yet.
Okay. Why don't we give the poll about another 10 seconds, and then I can go ahead and close that.
Okay.
And
Maybe if I
so,
could talk about Anritsu in the meantime.
yes, please. That would be great.
Okay. Anritsu is a global provider of test solutions for many different markets. One of the markets we specialize in is wireless, of course, and due to the high rate of growth of LTE, that's one of our core markets. My specialty as a business development manager is test for wireless devices, that being somewhat different from testing of base stations, infrastructure, and so forth. So in my presentation, I'll talk a little bit about the life cycle of wireless devices and then how test integrates into that overall design cycle.
Great.
Go ahead.
Yeah, I'm just going to share our poll results real quickly here so that we look at where our attendees think that folks will be building LTE devices. Hopefully, it looks like the majority look like North America. Then we have China also, and trailing there are Mexico or Brazil and Asia Pacific. And so now we're going to go ahead and get back to your slides, Mike.
Thanks very much. So this slide is intended to show a multi-stage process for wireless device design all the way out to the consumer, and then even repair following the consumer step if the device is broken. This could be applied to LTE devices, of course, or it could be GSM, WCDMA, CDMA 2K, any other type of devices. Typically, all these steps are split apart into different types of companies. For example, there's a block of baseband chipset and operating system. Typically, those are components or building blocks for the wireless device. Those would be done with different companies. Baseband chipsets, of course, Qualcomm's very famous. I think Venkat had mentioned a few other providers of chipsets. Operating systems, of course, there's several on the market. I kind of hesitate to name specific names. But those would be used as developed by themselves to begin with and OEM or original design manufacturer, a company that would design something and then somebody else would put their brand on it. But one of those two would use these baseband chipsets, OS, other components, put together a real-world device. Whether it's a smartphone, a tablet, a telematics device that goes into a car, whatever the device may be. Common between those, that device needs to go through conformance test, and that could be either conformance test for GCF or Global Certification Forum, or in North America, most probably PTCRB or PCS type certification review board. And that's a global conformance criteria that network operators usually require before launching a device on their network. In addition, there are typically operator-specific tests, CAT tests, carrier acceptance tests, that are required by a network over and above the global conformance type of testing. Once all that's okay, you can actually go out, build the device, and ship in volume. That could be done at OEM factories. For example, the major names might have their own factories that they own, possibly China, Brazil, Mexico, that type of thing. The trend seems to be to go to outsource manufacturing or electronic manufacturing services, sometimes called outsourced factories. Rather than use the OEM factory, use an outsourced factory to build the device. Go through some distribution channel to the consumer, then if it breaks, you might have an aftermarket service, reverse supply chain to automate repair of the device and return back to the consumer. So actually the arrow goes both ways, back and forth to consumer to the aftermarket service block. Next slide, if you could, please. So Anritsu offers a family of several different solutions to fit with the requirements of each of those steps. I guess the requirements from each of those are enough different that you can't have the same wireless test solution or maybe the same one-box tester. Our approach is you have different solutions to fit with the requirements of each of those steps. So you can see in the R&D step, that might be an R&D step at a chipset manufacturer, possibly an OEM building a device. We have base station simulators, the LTE simulator that we offer, the 8430 is shown. You might want to offer real-world fading to simulate a real-world environment. So we have a fading simulator and so forth. Later on at the device test stage, you might want to do functional test. We have a tester also capable of LTE for that. You might also want to do physical layer tests. We have yet again another third tester, base station simulator, physical layer tester for that. For the steps I mentioned about certification test per GCF or PTCRB, as well as carrier acceptance test, we offer two systems. One test system specialized in RF, another specialized in protocol, and support for all most of the major carriers in North America, as well as other carriers, Japan, China, and so forth. And last, some manufacturing solutions like our 8820, also shown previously. I think that's it. Back to you, Kelly.
Okay, great. Mike, I had one follow-up question for you. What do you think is the biggest challenge in getting LTE devices to market? Are we talking signaling RF conformance testing or operator-specific testing?
I guess in my point of view, there's a number of operators, each of which has different requirements, but the number and type of requirements for the operator testing or carrier acceptance testing seems to be exploding. Specifically in North America, where we have test plan after test plan after test plan. And the challenging part from my point of view is the fact that each additional test plan costs some additional amount of money to perform, both in terms of the amount of money required to buy the test scripts, the equipment, and then the time required to actually test the device. So in my point of view, the most challenging is carrier acceptance testing, specifically for North American carriers, but that's where the major part of the LTE networks in the world are currently.
Okay, great. Mike, Barrick from Anritsu, thank you very much. Folks, we are going to move into one more poll. Our last question is, when you design an LTE device, how important is pre-validation of the chipset by the chipset manufacturer? So we're going to go ahead and launch that poll, give our audience a couple of minutes to vote here. And in the meantime, panelists, we're going to move into our Q&A session, where we look at some of the questions that have been submitted by our audience, and we go ahead and take a look at those. And it looks like our first question is for Olga. In the device life cycle timeline that you mentioned in your presentation, does the 24 months include carrier acceptance testing?
Thank you, Kelly. Yes, it does. So basically, this is all the way from the chipset to consumer. And as I stated earlier, that any time period longer than that suggests less return on investment and lost early to market advantage.
Okay. All right, folks, I am going to go ahead and we've had about a minute here, so I'm going to go ahead and close out that poll so that we can take a look at the results. And so it looks like, and again, the question was, when you design an LTE device, how important is pre-validation of the chipset by the chipset manufacturer? Definitely seen as important. 88% see that as required. So let's go on to answering a few more questions here. Let's see. Hang on, let me pull up a couple of those. When talking about VoLTE and battery life, is it safe to assume that an HD call, meaning more quality of service or bandwidth for that call, would drain the battery even further? Olga, I think you might want to address that question specifically, but if we have any other presenters who would like to address that, feel free.
Thank you, Kelly. I would like to divert this question for Anritsu. They are the ones that are doing the testing. Mike, do you mind?
Yeah, sure, no problem, Olga. I think HD, first of all, is one of those terms like 4G. It's a marketing term that, to some degree, may not have much meaning because it's been used for so many things. And I think there are HD variants for CDMA, WCDMA, LTE that are really all completely different. But in terms of LTE specifically and VoLTE calls, there are two coder decoders or codecs that are used. There's an adaptive multi-rate wideband and adaptive multi-rate narrowband, AMR-WB, AMR-NB. And HD voice refers to AMR wideband. You use more spectrum. For voice, you get better voice quality. And yes, VoLTE calls by themselves, whether they're using AMR wideband or AMR narrowband, there are several reports in the press about draining the battery more quickly. And matter of fact, VoLTE deployments seem to be delayed to some degree because of the fact that VoLTE does drain the battery more quickly. So I guess the issue that I see is VoLTE, not necessarily HD, but VoLTE would drain the battery more quickly than standard voice calls, circuit switch type voice calls.
Okay. We have a public safety related question here that I'd like to throw out there and see if any of our presenters have an answer for. The question is, a couple of years ago it was proposed that land mobile radio, specifically P25 systems, would migrate and converge with LTE technology. The question is this still being considered? Now, I know that the FirstNet board is in the process of planning the new nationwide LTE network, but I don't think that they've gotten to the point yet of considering how the land mobile radio is really going to factor in there. Any of our presenters have perspective on this?
This is Mike again. I guess I could make a quick comment. From my point of view, FirstNet is putting together an LTE network, I've heard no consideration of integrating that with P25, so I suspect those would be run side by side in parallel and not integrated, but things can change quickly.
Okay. Great. I think we have another question here for you, Mike. In terms of carrier acceptance testing, what are you seeing Tier 2 and Tier 3 operators purchasing?
Some of the, I guess I could grade it depending on who you classify as Tier 2 and Tier 3. But from my point of view, Tier 2 operators, say less than, I don't know, 20 million subscribers, might use whatever the Tier 1 operators might use, assuming they use similar mixes of technologies, that type of thing, but with bands that are adapted for their networks. Tier 3 manufacturers, the smaller or very small carriers might use no testing for carrier acceptance. They might just say, if it's GCF or PTCRB validated, other carriers have deployed it, it must be good enough, so we'll deploy it too. I think that there would be quality issues associated with the Tier 3 approach that I described, but I've seen carriers do that.
Okay. It looks like we have a question for Venkat. Venkat mentioned TDD devices in the market. They want to know, is this in the U.S. market or in the China market? And how fast do you see TDD devices coming into the USA market? Do you think it will surpass FDD devices in the U.S.?
Okay, as far as TD-LTE devices are concerned, today TD-LTE devices are already available for the China market, India market, and the Saudi Arabia market. As far as U.S. market is concerned, given that band class 41 is required, some of the partners whom we are working with are likely to bring out these devices in the second quarter time frame. Given that Qualcomm specifically has multi-mode devices which support TD plus FD, and other ASIC vendors like Altair, Sequans, they already have TD chipsets which support TD-LTE only. We are likely to see some of these form factors in the second quarter, third quarter this year from the device OEMs.
Okay, great. And we do have a question for Wade, and I think this will probably be our last one. For Wade, what is the potential of VoLTE deployment in your network due to issues of handover testing between 3G and 4G?
That's a great question. The potential is certainly there. We're exploring it. In fact, we're preparing for it. Now, I don't see the challenge necessarily as one of handovers from 3G to 4G, both forward and in reverse, but necessarily for us, which would be the extensive coverage necessary to support LTE. Part and parcel with that would be combining various bands of our spectrum, as it is situated in different parts of our footprint. So band availability for those, but those band combinations in the software developed by Qualcomm and others needs to be available as well. And then finally, there's been some challenges with E911 in the past and things that we just need to test and make sure that we overcome. But those are the challenges. So I don't really see it as a handover challenge so much as the other.
Okay. Great. Well, I'd like to thank all of our participants today from Frost & Sullivan, Spire, Alcatel-Lucent, and Anritsu. We are also sponsored today in part by Brightpoint and Ingram Micro Company. Thank you all so much for participating, and this webinar will be archived on our YouTube channel. Thank you so much, and have a good day.